Dear students, so in this class now let us discuss about an integral equation. Now we are going to our third module, integral equations. So what is an integral equation? We know that a differential equation is an equation in which the differential coefficients are present. So like this integral equation is nothing but integral equations are the equations in which an unknown function appears under the integral sign. So like that, suppose integral f of x dx equals 0 or integral f of x into g of x dx equals 0 and so on. If f of x is an unknown function, then integral f of x dx equals 0 is said to be an integral equation. So here we discuss about the linear integral equations. An integral equation consists of number of variables, any number of variables. So the standard form of an integral equation is, it is h of x into g of x equals f of x plus integral a to b kxt g of t dt. So this is the standard form of a linear integral equation. h of x into g of x equals f of x plus lambda into f of x plus lambda into integral a to b kxt g of t dt, where a, b and lambda are constants. Here h of x, f of x and k of xt are the functions in x and t, as well as g of x or g of t, which is an unknown function. Here this kxt, this is known as the kernel. This is known as the kernel of the integral equation. This kernel is also known as a separable kernel, or a degenerate kernel, separable kernel or degenerate kernel, if this kxt can be expressed as the sum of finite number of terms, that is kxt sigma I ranges from 1 to n ai of x into bi of t. This kxt is the kernel of the integral equation, and the kernel is said to be a separable kernel or degenerate kernel of the integral equation if that kernel is expressed as a sum of finite number of terms, that is kxt sigma I ranges from 1 to n aix bit, where there is each of which is a product of a function of x and a function of t. Means it is expressed as a sum of finite number of terms, then that kernel is said to be a resolvent kernel or separable kernel or degenerate kernel. Okay, separable kernel or degenerate kernel. Here h of x, f of x, kxt are the functions, but g of x is an unknown function which is under the integral sign. Then come to the standard form. The integral equation can be classified into two. So consider this equation. H of x into g of x is f of x plus lambda integral a to b kxt g of t dt. If a and b are constants, consider the integral limits. If a and b are constants, then this integral equation is said to be a Fredholm integral equation, Fredholm linear integral equation. If the limit of integration, that is both a and b are constants, then the given integral equation or the standard form is known as Fredholm integral equation. Moreover, if h of x equals 0, what happens here? Then the equation 1 reduces to, it is f of x plus lambda into integral a to b kxt dt equals 0. So this is the Fredholm integral equation of first kind. So this is the Fredholm integral equation when a and b are constants, and if h of x equals 0, then f of x plus lambda integral a to b kxt dt equals 0, which is called as the Fredholm integral equation of first kind. Again, if h of x differs from, suppose h of x equals 1, suppose h of x equals 1 and f of x differs from 0. h of x equals 1 and f of x differs from 0, then this integral equation is said to be, the integral equation 1 is said to be inhomogeneous Fredholm integral equation. Inhomogeneous Fredholm integral equation of second kind. If h of x equals 1, then and f of x differs from 0, so 1 reduces to g of x equals, it is f of x plus lambda integral a to b k x t g of t dt. This equation is said to be an integral equation or inhomogeneous integral equation of second kind. Inhomogeneous Fredholm integral equation of second kind. Okay. Again, if h of x equals 1 and f of x equals 0, then 1 reduces to h of x equals 1 and f of x equals 0, then g of x equals lambda into integral a to b kxt g of t dt. Then this integral equation is said to be a homogeneous Fredholm integral equation of second kind. So this is the first classification. If both of the limit of integrations are constant, then the standard form is said to be a Fredholm integral equation. And if h of x equals 0, then f of x plus lambda integral a to b kxt gt dt equals 0, kxt g of t dt, kxt g of t dt equals 0 is said to be Fredholm integral equation of first kind. Again, if h of x equals 1 and f of x differs from 0, it is the integral equation known as inhomogeneous Fredholm integral equation of second kind. And if h of x equals 1 and f of x equals 0, then the reduced integral equation is known as homogeneous Fredholm integral equation of second kind. Similarly, if a is a constant and b is a function, or b is a variable, not a function, b is any variable, suppose it is x. If a is a constant and b is a variable x, then this integral equation is said to be a Volterra integral equation of first kind, or Volterra integral equation. If both of the integration limit of integrations are constant, standard form is known as Fredholm integral equation. If the upper limit, lower limit a is a constant as well as the upper limit b is a variable, suppose it is x, then this integral equation h of x into g of x equals f of x plus lambda integral a to x kxt g of t dt is known as Volterra integral equation. Moreover, here again if h of x equals 0, then it is f of x plus lambda integral a to x kxt g of t dt equals 0, then it is said to be Volterra integral equation of first kind. If h of x equals 1 and f of x differs from 0, then the integral equation g of x equals f of x plus lambda integral a to x kxt g of t dt is known as inhomogeneous Volterra integral equation of second kind. Moreover, if h of x equals 1 and f of x equals 0, then the integral equation g of x equals lambda integral a to x kxt g of t dt is known as homogeneous Volterra integral equation of second kind. So this is the classification of integral equations. Agree. Now consider this. What is this kxt? Kxt is known as the kernel of the integral equation. If this kxt equals ktx, means then the kernel is said to be a symmetric kernel. Kernel is a separable kernel or a degenerate kernel if the kernel can be expressed as a sum of finite number of terms, that is sigma I ranges from kxt, sigma I ranges from 1 to n, a of x into b of t. If kx is kt of x, k of tx, then means this is the symmetry of that kernel, so that kernel is said to be symmetric kernel. if an integral equation with a symmetric kernel is said to be a symmetric integral equations. Okay. Now consider two important results. So one of them is familiar with us. That is the one integral equation for one result is integral a of x, or in the s. We know that this result integral ax to bx f of x theta d theta f of x theta d theta equals, it is f of we know that it is f of x theta, sorry, f of beta x or bx into b dash x minus f of x and x ax into a dash x plus integral ax to bx del by del x of f of x theta d theta. So this is a well-known result. It's a familiar result with us because we used this result in previous chapters. That is integral alpha t to beta t f of x t dt. Like that, integral a of x to b of x f of x theta d theta is f of x b of x b dash x minus f of x a of x into a dash x plus integral a of x to b of x del by del x or fx of f of x theta d theta. Again, consider another result, that is multiple integral a to x, multiple integral of integral a to x f of theta d theta etc. d theta, that is, it is n times. This result is equals, it is 1 by n minus 1 factorial into integral a to x minus theta f of theta d theta, sorry, all power x minus theta all power n minus 1 f theta d theta. These are two important results. This is very important, this is crucial for the further chapters. That is, the second result is, the first result is integral a of x to b of x f of x theta d theta is f of x b of x into b dash x minus f of x a of x into a dash x plus integral a of x to b of x del by del x f of x theta d theta. And the second result states that multiple integral of x and integral a to x etc. f of theta d theta into d theta etc. d theta, that equals 1 by n minus 1 factorial. If it repeats n times, then it is 1 by n minus 1 factorial integral a to x minus theta all power n minus 1 f of theta d theta. Okay. By using these two arguments, we can try to solve a problem. That means, consider y2 dash equals f of x. y2 dash equals f of x, which satisfies the boundary conditions with y0 equals y1 equals 0. y0 equals y1 equals 0. Then prove that y of x equals, integral 0 to x into x minus theta f of theta d theta plus integral plus x into integral x to 1 minus theta f theta d theta, or theta minus 1 f theta d theta. How to prove this one? By using the above two results. That is, by consider y2 dash is f of x with the boundary condition y0 equals y1 equals 1, so 0, then we have to show that y of x equals integral 0 to x minus f of theta d theta minus x into integral 0 to 1 minus theta of theta minus 1 f of theta d theta. And it can be reduced of the form y of x equals integral 0 to 1 kx theta f of theta d theta, where kx theta is the kernel, that is theta into x minus 1 if x less than theta, theta less than x, and x into theta minus 1 if theta greater than x. So how? Solution is, consider this one, y2 dash equals f of x. Then you can integrate this result or this equation from 0 to x with respect to theta. So that means integral 0 to x y2 dash theta d theta equals integral 0 to x f of theta d theta. You can integrate on both sides of this equation with respect to zeta and from where to where 0 to x. So what is integral 0 to x y2 dash theta d theta? It is y dash theta minus y dash naught. Y dash theta, it is y dash theta minus or y dash x, y2 dash d theta, y of x minus y dash naught. Simply it is from 0 to x, so it is y dash x minus y dash naught equals integral 0 to x f of theta d theta. Okay. If you integrate this y2 dash theta with respect to theta, then it is y dash x minus y dash naught from equals integral 0 to x f of theta d theta. You can again integrate this with respect to theta from 0 to x. So what you get? That means again integration you have integral 0 to x y dash x dx minus integral 0 to x y dash theta d theta equals integral 0 to x again integral 0 to x f of theta d theta. F of theta d theta d theta. Agree? So that means what is integral of y dash theta? It is y of x. Y of x minus y naught minus y dash naught, which is a constant. So y dash naught into integral d theta. Integral d theta means theta itself. From it is x, so it is x into y dash naught. Why? Because if you integrate this one, means integral 0 to x y dash 0 d theta equals y dash 0 into integral 0 to x d theta. That equals y dash 0 into theta from 0 to x. That is x into y dash naught minus 0 into y dash naught. So it is x into y dash naught equals, according to our research, multiple integral or nth integral 0 to or integral a to x f of theta d theta etc. That is 1 by n minus 1 factorial x minus a or theta or power n minus 1 into f of theta d theta. So using that result, so what I get? It is equals on right side it is integral 0 to right side is integral 0 to x, it is x minus theta f of theta d theta. Okay, x minus theta f of theta d theta. That means y of x minus y naught minus x into y dash naught equals integral 0 to x minus theta f of theta d theta. But by the condition, what is y naught? Y naught equals 0. So this term reduces to 0. So it is y of x minus x into y dash naught equals integral 0 to x this one, or y of x equals x into y dash naught plus integral 0 to x minus theta f of theta d theta. Okay, mark it as equation 1 or 2, not okay. Come to the initial condition. What is y1? y1 equals 0. y1 equals 0 means the left this equation. So here y of x equals x into y dash naught. Under this condition, y1 equals 0. So left side is 0 equals x is 1. So y dash naught plus integral 0 to x, it is x minus theta, it is f of theta, 1 minus theta, replace x is 1 minus theta f of theta d theta. So what is y dash naught? This means y dash naught equals, this means y dash naught equals minus integral 0 to x, sorry not x, it is 1, minus integral 0 to 1 minus theta f theta d theta. Okay. Therefore this equation reduces to, therefore 1 gives, therefore equation 1 become, it is y of x equals x into y dash naught. What is y dash naught? It is minus x into integral 0 to 1 minus theta f of theta d theta plus integral 0 to x minus theta f of theta d theta. Okay. That means y of x equals integral 0 to x, first term, integral 0 to x, come to us last term first, x minus theta f of theta d theta, then f of theta d theta minus x into integral 0 to 1, x lies in between 0 and 1, so it is integral 0 to x, it is 1 minus theta f of theta d theta minus of plus minus integral x to 1 or x into 1 minus theta f of theta d theta by using intermediate theorem. Integral 0 to 1 can be split as integral 0 to x plus integral x to 1. Okay. So that means y of x equals integral 0 to x minus theta of theta d theta minus integral 0 to x into 1 minus theta f of theta d theta. So that means it is integral 0 to x, which is common there, f of theta into, what remains here? It is x minus theta minus x into 1 minus theta d theta. Okay, from here limit of integrations are same, so it is 0 to x, f of theta is common, f of theta into x minus theta into x into 1 minus theta d theta plus integral x to 1 x into theta minus 1 f of theta d theta. Okay, or minus x into integral x to 1 minus theta into f of theta d theta. Agree. That means then that is y of x equals, it can be rewritten as, that means y of x equals, it is integral 0 to x f of theta into x minus theta, there is minus x and plus x cancelling each other, it is x minus theta minus x theta, so it is f of theta into, it is